Hi, it's Jocelyn. I'm back. It is late August 2026, and with all the really warm weather and gross smoky air, I think it is a great time to solve last year's Advent of Code. This year, I'm going to solve the problems with as many weird devices as possible, starting with this Garmin Forerunner 265S. I got this watch when, after a long winter run, 20 kilometers into the run, my Apple Watch, which I had just charged, decided it was too cold. This watch does not do that. I charge it every week or two. It's very dependable. Love it. Um, Thankfully for Advent of Code 2025, you can solve or you can program this device using a cursed language called Monkey C. I hope that you stick around. Let's look at day one. This problem, like many problems in my experience, start with people discovering project management. In this problem, there is a dial that starts at 50, and we rotate it using the instructions that it gives us. What we want to see is how many times the dial is pointing at 0 after an instruction. Here we have a pretty short example. They give us a longer puzzle input, but we hopefully can get a pretty animation from this. The Linux SDK is a bit annoying to set up, especially if you are on an ARM machine like I am. Everything is in at least on Linux, is in the .garmin folder in your home directory. For this, we're just going to make a simple watch app. So I'm just going to copy this template. You can see the monkey.jungle file. Jungle is like a project. They give us a manifest file, which they recommend not editing. Usually you would just be editing this using the commands in Visual Studio Code. We're going to completely ignore that instruction, of course. They also give us some samples. If we want to do an animation, we'll probably at least want to draw a circle. I'm going to see if we can find samples that have circles. And here we see that there is a few. There's a looks like there's a true type fonts radial text file, which looks promising to me, and that is in the true type font sample. So we're going to look at that in addition to templates. So just going to open that in another tab. Look at the manifest file. So they give us an application ID, which has a UUID. It looks like this 4 means it's a type 4 UUID. Which means it's random. So we can like add one there using the UUID gen command, and has a new line at the end, so we'll delete that. And we just have another lovely, again, version 4, because of that 4 right there, UUID. There's a type, as we hoped for. It was a watch type. I'm not sure why it's not filled out in there, but that's fine. That's from a resource file. Yep. And then we need an entry. For the entry, we will say here's the app, which we'll define soon. Launcher icon will be, I guess they want a drawables resource file there. We'll do that, it's fine. And for the min API level, we'll see if we need anything beyond 4.2.1. It's presumably better to support more devices, but that's fine. For our products, we just care about the one we are testing, the best watch, the Forerunner 265S. I don't think we'll need any permissions, and the app is in English. All right. Okay. Now we can. Yeah, we said there was a launcher icon first of all. That was in drawables. All right, and right now there's an SVG file. I think, let's see, here we have a lovely, lovely favicon, which is, let's see, 64 by 64. I believe that the watch icons are supposed to be 60 by 60. Hopefully that's close enough. We'll do that. -O to, let's see, resources, drawables, and that will be launcher icon.png, and we can remove the launcher icons.svg. And if we look at that, we have hopefully a much nicer icon. All right, so that is our manifest. As we see here, we have some things we need to fill in. So I guess we can just look for all of them. We could use sed. We could also just search. There's not that many. We can just search for them in Vim, I guess. So there we go. So view class name will be AOC view. That will be this mini delegate class name. That will be for like if you press the slide button to see that menu. So and to make sure that the SDK is in your path, and then we can call monkey C. Well, we can look at the help for monkey C. It tells us what we're supposed to have. We need a jungle file, so the project file. We just say what device you want to compile it for, what we want to call it, and even for development apps, you need a developer key, which you can generate yourself. It's there's instructions on the Garmin site, but we're just going to compile and see what happens. It looks like it just built. I'm a little bit surprised that just worked, but we'll see what happens. So I have the device plugged in. It's available over like MTP. So the way you can do that in Plasma, like in KDE, is using KO client copy, and this will copy the file we just generated, fr265s.prg, to that devices Garmin/apps folder, and when you eject it, it will verify it, and then it gets deleted from that folder, but it's installed now. So it says it's been installed. I'm gonna show you how you launch them. Usually it's the same way you start a run or whatever, except it should be at the bottom, AOC app, and then we get our lovely view. So let's look at that AOC view. It has a layout. Res is kind of like, that's also a resource, so you can look at layouts. And here it has the prompt and a monkey. We're going to delete that monkey, and just this entire layout, and also the prompt. Okay, that's great. And just do nothing. We don't have any resources to load. We're going to just draw everything. The SDK also has documentation, and so I just open the documentation for device context, which is kind of like a Canvas 2D, lets us draw things like a circle or whatever. So this onUpdate function is how we will render whatever we need to render. All right. Just before I get confused later, because I know I will, on show and on hide, I'm going to put them beside each other. I mentioned earlier there were some samples, and this true type fonts radial text file looked promising. So we can open that up in another tab, and they also have on update, which has like a draw circle and other things. So we're gonna kind of steal some of the code here. All right, so we can start by clearing our context, and probably want some colors. I think we should have Christmas colors. So what's a good Christmas red? Sure, that looks fine. And then Christmas green, it'll be a little bit darker than that red, I think, because if we do like, that's too bright for Christmas green, so yeah, I like that. That's nice. So we will start with maybe probably white foreground for now, and then a nice green background. All right, and then we can clear it, and then they also give us a way of getting, I believe, the width. Yeah, there's the width and the height of the device. Obviously, it's a circle, so to be a bit careful. I don't know, maybe half of CX was the full thing, so maybe divided by 3. I'm also noticing now these are numbers, which are, I believe, integers. I'm going to make these all floats. Will that work? What type is that? That's a float. So it looks like that is enough to get us floats. Great. Okay. I don't really trust the types though. I'm just gonna explicitly do that here. Okay, so now we need to draw a circle, which looks pretty straightforward. The third one should be the radius. Yep, radius. We'll just say radius. All right, let's see if that works. So we need to monkey see it, and then we need to copy it over. Okay, so if I just do this right now, it will fail. It will say we can't write to it, and that's just because it's not currently in MTP mode. It's just charging. One way to do this is to unplug it and plug it back in again. If you do that on the USB-C side. The Garmin connector is pretty unreliable. It's even a bit dodgy if you're only plugging it in and unplugging it once a week. So be careful. But the other way you can do it if you don't unplug and plug back in the USB cable is going to System and then USB mode and just selecting MTP. And now it's gone from charging mode to MTP. And then I got a notification that it is connected and I should be able to copy it now. All right. So now we start our AOC app and we have looks smaller than I would have expected. Oh, sorry, what am I saying? I said CX. That will just be dc dot get width to float divided by 3. That will make more sense. All right. The example here also gives us some radial text. I guess that's kind of the whole point, which looks fun. So let's do some radial text. So there's a get first available true type font function here. And I know Bionic Bold is their weird like number font on these devices. So we'll do that. So to actually get the font, it's graphics.getVectorFont, the face name and the size. So let's try, I'm going to say Bionic Bold. So that's just the syntax for like a map. And then size, let's try 16. And we'll go up if we need to. And then for drawing it, we have our font. Okay. Let's try drawing a 0. Okay, so says degrees, undefined symbol degrees. That makes sense. Let's start at 0 and see what that is. Justification. What do they want there? There'll be graphics, text, justify, whatever. So probably center and decenter. The radius, that would be the radius probably plus amount if we're centering it, so that's 8. And then the orientation, radial text direction clockwise. Okay. Cool. Let's try seeing what this looks like. It's not patient enough. This is a trend. All right. Okay, that is very small, but we see our 0 right there. I believe 0 should be at the top, and then we'll want 50 over there. So let's see how that goes. So I'm thinking for this probably like 64. The positioning looked good though, so 64 divided by 2 is 32. It's going to be clockwise, so that should be 270 then, right, if we're doing clockwise? Is that the way it works? I don't know the way it works. Let's find out if that's the way it works. I was wrong. This must be for something other than... Well, what does counterclockwise then do then? Oh, it's whether the top of the text is further from center or the bottom text is further from center. Okay. I'm not sure why that's clockwise or counterclockwise. Maybe somebody in the comments can explain that to me. But either way, 90, I guess, is what we want for at the top. So it's going to be helpful right now to have a number to angle function. So I'm going to implement that now. Number as lang numeric. We need to import lang, and we can see that a numeric is a number or a float or a long or a double. So we will take that number, divide it by, well, first I'll make sure that it's a float so that we're not accidentally doing integer division. Multiply that by 360. And then we saw that we needed to add 90. All right, and we can take our waypoints here. Just every quarter of the circle. If I can spell. Has the right type. And now we have our angle. All right, let's see if that works. We will start by pointing at 50. So let's get a current position recorded. And let's change this to, let's see if we subtract the current position. Does that work? Let's see if that does what we want. And then we will also want to draw a line from the center, and then Cx is going to be the same, and we want it just like up, which I believe is going to be lower Cy. So we'll say Cy minus radius, and we'll see what this looks like. All right. Cool. Now it is pointing to 50, and if I rotate it left, it will go down past 0, and it get to 82, and then I'll rotate it left again, and that will go to 52, which is correct. So, but let's just now add a timer and try to get it to rotate. So we can look at the documentation for timers. Have a timer class right there. We can create one. I'm just actually, instead of on layout, just going to do this along with everything else. And then it says that we need to start it. I'm actually also going to do this like on show, and then on height I'm going to stop it in case you like enter and exit it or something. And or I'm going to say on timeout. We'll just say current position and then also we're just going to modulate by 100 here just what stays between 0 and 99. And then we see here we also need to request update. Probably watch UI. Perfect. All right, let's see what happens. That is not rotating. Oh, it is rotating. It's rotating very slowly. It's rotating once per second. So as you can see here, as we are increasing it, it is rotating right, which is what we'd expect. In the example here, if we are at 52 and we add 48, that goes up to 100, in which case you modulo. So before I get too lost here, I need to keep it really simple. Right means increase, left means decrease. And here with increasing, we are rotating right. So this is way too slow. I'm going to set it to 1 to be as fast as possible. It's not actually going to be 1 millisecond because this is throttled, but I don't want to slow it down more than it's already be slow. All right, so now we're going to take a look at our sample input and try to rotate it according to these and see what happens. So we'll take here. Thankfully, it does support multi-line inputs. It does not, however, support split, so this should be a string. That doesn't get typed automatically in Monkey C. And then, so like I said, it doesn't have splits, so instead what we're going to do is on our timeout, we're going to look for the next command. That would be, let's see, find, and we'll find a new line, and that will give us an index or null. So if the index is null, then we're just going to return. I'm going to get a substring from the start to that new line. Substring, and the arguments are the start index, which is 0, and then the end index, which is just going to be index. And then I'm going to take our input and just go right. So, and null just means continue on forever. And I believe it should be index plus 1 because you need to count the new line in that. Okay, now we want to look at the command. They're actually Unicode strings, which is great, but the characters can be of different lengths. It does mean you need to convert it to a char array first. So we'll do that. We'll look at the first index, and that will be the start. And if start is left, then it is a left command. And if it is right, it is a right command. And before we get too confused, I'm going to copy this here, and it says that right is an increase and left is a decrease. Amazing. I'm now going to take the second part of this to be the numbers. So wonderful. And this is going to be the number, just not including the first bit. It's just going to be remaining delta. And we're going to say that if we are returning left, then our remaining delta is a decrease of amount dot to number. And if it is right, then it is an increase of that number. All right, now what we're going to do is if we have any remaining delta, instead of reading the next command, we are going to just move the current amount. Okay. I do want to do some logging, so to do that, there's a lovely system.println function, and I'm just going to do this when we initialize. For each timeout, I'm going to look at what our command is. Start, and then the amount. To actually get a standard output, you need a file that has the same name as the program, except with txt, and we're going to copy that to logs. Now we need to start actually counting the times that it gets to 0. So to do that, I'm going to call, I think, generally the answer score. So we'll start at 0. We will render it. So we'll just render it right at the center. Same font as everything else should be good. And we also need the text. That will be score.toString. And we need justifications. That's just going to be centered. All right. And then, of course, we need to update the score. So to do that, we will look at our timeout function here. Whenever we've completed an action, we will check to see if we should increase the score. So to do that, so if we're not going to be moving in this movement anymore, and the current position is 0, then we increase the score. I also think it might be nice just to render something when we are like at 0. So I'm going to say if we're not moving, so if the current delta is 0 and the current position is 0, then we're going to render it in Christmas red instead of Christmas green. Current delta, or remaining delta. I'm just going to double check up here, make sure I got that right. Remaining delta, current position. Okay, let's see if that works. All right. Ooh, I bet we're not doing the modulo here. In fact, I know we're not doing the modulo here. So that's what we need to do next. And then same over here. So since it doesn't handle negatives correctly, we're going to say -1 plus 100 modulo 100. Or at least I'm not sure if it handles them correctly. I don't want to find out. It's fine. Let's see if that works. What am I doing wrong? Oh, that line might do it. Okay, hopefully it's just that. And that also fixes the jump. Beautiful. Oh, that's gorgeous. Okay. Um, this is very slow. It looks correct, but it is very slow. It is taking a long time even for our sample input that is not like 4,000 lines. So what I'm going to do now is just make it go a lot faster. So what I'm going to say is when it's not 0, I'm going to take the sign because there's no good absolute functions, which is just if the remaining delta is greater than 0, then it's going to be positive 1, and otherwise it's going to be negative 1. And then what we can do is we can say the jump is half of the remaining delta, but we want that to be at least 1, so it could just be math.ceil. However, if it was math.ceil and it was negative, I'm not really sure what that does, so you can just multiply that by the sign before and after. And that is going to be at least 1, up to just above half of the remaining delta. Then what we're going to do is we're going to take the current position, and we're going to say it's the current position plus the jump, modulo 100. We also need to, if it's negative, we need to handle that as well. So we'll do that same trick over here. And then we'll say the remaining delta is decremented by the jump. We have to be careful here. Here we increase the current position, decrease the remaining delta. It's the same thing here. The jump here, this whole thing, we know it's an integer, so just to be consistent there, I'm going to cast it to a number. And then I think the rest is the same. And we can now get rid of that. And I think that we should try running this. So there we go. That's much nicer. And just as a second sanity check, we see that it's 3 and it's ending around 32. That looks like 32 to me. Okay, so now we have this giant puzzle input, and we're just going to replace our sample with that and hope for the best. Yeah, actually there should be a new line there. And let's give that a try. So this I already can tell is going quite slowly. I'm just gonna kind of cheat and make this like really fast. There we go. And then we'll just let that do its thing. All right, I think that's our answer. Shall we see if it's right? So if we go to Advent of Code and input it, it says we got a star, which is wonderful. Part 2, which is hopefully easier now that we have a dial that spins in the right direction. All right, so now we need to use password method 434C49434B. Let's see, so it's 43C, CL, CLI, CLIC. Yeah, click. Okay, so using password method click, what is the password to open the door? Instead of counting the number of times it lands at 0, we need to count the number of times that it passes 0. And it gives us a warning, which is that if a dial pointing at 50, a sync rotation like R1000 would cause the dial to point at 0 10 times before returning to 0. Which, okay, yeah, there are some that are larger than 100, so that makes sense. All right, so just for time again, I'm going to kind of comment this out, and we're going to solve this in a really dumb way. So I'm going to create a for loop, and then it's going to start at 0. It's going to go towards the absolute value of jump, and stop when we get there. Then we are going to not duplicate current position. We're instead just going to adjust it like this. And if the current position is 0, then we increase our score. All right. I think this looks good. Yeah, okay, so before we try this with the very, very long input, I do want to try this with the small input. And it should give us a number here. It says that for the first example it would be 6. I also do want to kind of improve the way we make it red, because right now it only turns red when we stop at 0. I'm just going to make a Boolean, which is or past or switch directions at 0. So we'll just say score increased, and we'll set it to false. And if we increased the score over here, then we'll say increased score equals true, and otherwise it will be false. Increase score. Did I misspell that somewhere? A score increased. Whatever. Either way. Okay, and then will just be, if we've increased the score, then set it to red. All right, let's see if this works. Beautiful crash. Maybe you see what's wrong already. So we have looks like it did not finish. It did read the first command, it looks like. That looks like, was that right now? That was right now. Line 49. So on line 49, we have an integer added to a float, which is not allowed. So it'd be great if the type system they've kind of bolted on warned us about that kind of thing. Other thing I noticed is in this example here, it needs to end in a new line. And it's just because of the way we do our string handling. We could have checked for new line or the end of the string. We don't do that. We just check for new line. So we need that new line there. That out of the way, we can copy it over. And then all right, we see there that it ends with 6 and on 32. So I think that is good. Let's now, I guess, run this with the full giant input. All right. All right, looks like we probably have our answer. We better have our answer. 6379. Amazing, and we got it right. So that is day one, and we have our 2 stars. Next up is the BlackBerry Z10, which is very special to me.